If you don't know me, I'm Neil. I'm the head of sales here at Axoflow. I sit in New York.
Yeah, my name is Balazs. I'm a CEO at Axoflow and also the founder of the Syslog project. So that's about me, Sándor.
Yeah, hello, my name is Sándor Guba, and I'm CTO at Axoflow, and especially interested in labels, as in our former company, we created logging operator, which based on for Kubernetes logging, and Kubernetes is very much about labels, in my opinion. So I hope that I can show some interesting stuff today.
Yeah, that's actually a great place to start. Thanks, Sándor, for mentioning that, because I'm really excited about this, not only because you're going to learn a lot about labeling data and how those labels can really empower users, but also I think labels are a really important differentiator between Axoflow and all of our competitors that are in the pipeline space. If you have experience with labels and Kubernetes workflows, this will make perfect sense to you. If not, what hopefully you'll come away with is an understanding of how fast and easy you can use labels to do a lot of really cool stuff with your data. So with that in mind, the agenda for today, we'll talk a little bit about the old way, meaning, how most of you are, collecting, normalizing, routing data to your security, information event management engine. I was just going to take us through the possibilities of labels. That's a pretty interesting section. And then Sándor's going to show us labels in action. So as I mentioned, let's start first with a little bit about the old way. Of course, detection engineering is complex, it's expensive, and it's knowledge-based. It's based on, the kind of understanding that the engineer has, not only about the data sources themselves, but also about the destinations that you're trying to route the data to. It's really hard to classify that data. If it doesn't come in the way you were expecting it, it can be really difficult to track that down and figure it out. And we've been living for 20 plus years in this sort of fire and forget environment. The problem with that is, while you're in the dark, you also need to maintain all of it. And it's really hard to maintain something that you can't see or necessarily understand in real time. And that's one of the big things that Axoflow does. Axoflow turns on the lights. And of course, the background on all of this, what's driving all of this change in this security data collection piece, is that there really is way too much data anymore. The data growth rates are 28% year over year. Unfortunately, 50 to 80% of your security data is probably redundant and leads to really noisy queries, and you miss a lot of queries that don't even fire. So these are all things that for the most part, why people attend webinars like this is to figure out how they can gain better understanding and get their security costs down. And we're going to show you how labels can help with all of these problems today. So with that, I'm going to turn it over to Balazs.
Yeah, thank you, Neil. Great point on volumes, that them being a problem. But what we would talk about today, and where I would start, is not talking about volumes, but talking about complexity. The complexity of the data flows that has also increased dramatically in the last 20 years or so, ever since I was part of this space. So we always imagine that data is going through these simple funnels, a firewall or an access gateway produces security relevant information that gets all absorbed into a funnel, and then we feed that to whatever SIEM we have, and as simple as that. But if we dig down, we will see that we have locations, we have data centers around the world. We have hundreds, or if not thousands, of applications that we need to run. And of course, we have different data source types. So maybe we are running Palo Alto or SonicWall or FortiGate, whatever firewalls. We have all these systems running, and we need to collect security relevant data from them. And if we look at these numbers, hundreds of applications, tens, if not hundreds, security tools, all this, these are actually not a single funnel, but rather even thousands of data flows connecting specific data sources to specific destinations. And each of these data flows can do something specific to that combination. So maybe you need to fix a timestamp because a time zone is missing, or you need to find the real data source because the IP address was masked by network address translation. You will have to do something specific with the data that's coming from a data source as it is going to the seam so that it remains usable. And if we multiply that with the amount of connections between data sources and the destination, we come up with this huge rule base, thousands of rules, and sometimes you basically forget why you did stuff in the first place. I mean, it's really difficult to remember why we did something 5 years ago. And well, this is a management problem. And I think that the industry has shown a solution for large-scale management in the management of IT infrastructure, and that's basically the pets versus cattle metaphor. Back when I started my previous company, we started to use names for our servers from the Snow White tale. So we were using the names of the 7 dwarfs, which is obviously a real scalability limitation because we could only have 7 servers. But anyway, we logged them on every day, checked out if backup worked, if the services those servers provided are all right, and just took care of them. And if one of these servers broke down, then we scrambled there to fix it and bring it back online so that everything could work. And yeah, so there is an inherent scalability problem here if you are managing our IT this way. The cattle approach is very different. Instead of creating bespoke servers, we're standardizing. We're trying to make our systems as uniform as possible. We are automating everything, provisioning, monitoring, everything that you need to operate these systems. And whenever something breaks, we're not fixing the specific piece. We're just replacing them with a new instance, and that's it. So the way cattle-like management works is, I think, worth learning from. And if we look at the tools in this space, be that Terraform, Kubernetes, or even Argo CD, we will see that the structure or the concept behind these tools is very similar. These are all using declarative approaches to manage all that IT. And that's a major difference, being very specific how servers need to be run and creating runbooks and commands to execute. We basically use high-level descriptions of what needs to be done, and the system works out the rest. We apply the same idea to Axoflow or data flows in general. So instead of doing these imperative rule-based configurations, we do a declarative approach. What's the basic difference? So with imperative, you would need to open a port where you can receive, or a connector where you can receive data. Then you set up the data source so it sends to the appropriate port. Then you apply filtering, parsing, maybe even do some transformation along the way, and then you feed it to whatever destination you have. You're very descriptive. You need to work through all the details and create that configuration. Declarative, on the other hand, would mean that, okay, I describe my desired end goal, and that would be, let's collect firewall logs into Splunk. That's it. And let the system figure it out how exactly that needs to be done. So declarative really flips the idea of configuration management from an imperative model to a desired model, a desired end goal description. So, and with that, how we do that, I mean, labels obviously play a very, very important role here. And without going into very specific details, it really is important to describe the what, the objects, the resources in a system like this. And that's how we can apply our policies later on. So what are labels? I mean, labels are everywhere, and we are using them day in and day out. If you look at those two examples, containers and data flows, a container example would be something like in Kubernetes or a cloud environment where we associate context, we associate information to our resources and IT infrastructure, being, what kind of software we are running. It's stable at the moment. Is this container part of our prod deployment, or is that dev? Is it part of the backend tier or the front end, or who is paying these container? So these labels all make sense from whatever perspective, and they help automation because it makes it trivial to query and enumerate infrastructure that we need to run and operate. But the same idea can easily be applied to data flows. So obviously we are not deploying software on a data flow, but we want to know what kind of data source is generating that flow. which team is responsible for the specific flow, maybe for access control purposes. So these labels are basically attributes that we can associate with resources or objects in our system. And well, as I said, labels are not rocket science. You can find it in machine learning models, in issue tracking systems. They're regularly used in various solutions. The way we apply them to data flows is, I think, relatively is unique. Just to give you a couple of examples where labels make a lot of sense. First, I mean, if you remember my funnel description, let's assume that I have 10 terabytes every day going into the seam. And as long as it's just a single entity, 10 terabytes of logs every day, it's very difficult to reason about. But if you start associating labels with data flows, and you can start seeing the teams that are responsible for them, the applications that are those get generated by, you end up with this easy way to slice and dice into your data and get more understanding, and maybe get away with, I won't need this kind of data in my seam anymore because it's completely useless. Another way to use labels is apply a flexible logic like routing. I mean, I may want all my security tools to go to the seam, and with a simple rule like that, it's much easier to implement than having to describe everything in detail. And last but not least, labels make a lot of sense when creating access control policies and, RBAC to grant the required permissions for you as a tenant or the operator itself. So with that, you've seen a couple of examples how labels can be used. And so I introduced the complexity of data flows. I introduced how cattle-based management of data flows makes sense and how labels help there. And with that, I would hand over the mic to Sándor so that he can show a couple of things in the product itself.
Yeah, all right. Thanks, Balazs. That was very useful for understanding your demo. But after the theory, let's see some practice, which is my preferred way of learning. So for this occasion, I prepared my lab environment. I generated around 100 appliances on our topology view. And if you are not familiar with our product, the topology view is the physical connections between the log sources, the AXO routers, and the destinations. And this is already cheating because you are seeing some nice logos over here, and this is already because of the labels. So you should imagine like 100 identical boxes here, sending some data to AXO router and so on. But we got labels. So let's first just, quickly organize by vendor. And immediately those, 100, and our customers, we got thousands, tens of thousands of machines that we have to visualize. It's much easier to understand, what's happening in the infrastructure, what type of vendors, products are in my infrastructure, how much data they are sending. But we got other labels as well. Let's see a team label, for example. And this is another perspective, not organizing by the type of the logs, but who is responsible for different stuff. We got a couple of, Windows, network, security, and because we have those labels, we can just zoom into. So let's see security and see what type of appliances they are running. Yet again, this could be, hundreds, thousands. So that's still hard to follow, but let's organize that based on their location. And immediately, this is another perspective. So just, explaining what you see on the screen is we are filtering for the security team. So it's only the security team owned devices. And we group by location. So I immediately see where these machines located and to where they are sending their logs, which is pretty cool. Of course, we got these labels, this is a bit of eye candy. It's easier to understand, easier to provide evidence, where and how you're sending logs. Let's talk a little bit about where those labels coming from. So this is another view, the analytics. This is a real-time view of the data that actually passing through the AXO routers. And if you wouldn't use AXO router, any other product would be showing at least on the source IP addresses, the machine that collects the logs and the destination. This is the basic view, but it doesn't really tell too much around. So let's add those labels I was talking about. So we got the vendor, and we got the product label, for example, and immediately the site is changing. And Axoflow, based on just the content, without any configuration, automatically identifies the type of logs. So you can see, from where what type of logs are coming. And if you're managing logs, sometimes the receiving port is important. So now you can identify, where those appliances sending onto which port their logs. Or if you want to go deeper, you want the host names for that appliances, because IP doesn't telling too much, but like maybe a desktop host name can tell you what's happening. So with just the labels, we come from like a very nothing to say visualization to a very good understanding of the whole system, what type of logs I have, which destinations they are heading, how much percentage of each of these types adds to the whole view. And these are just labels based on the content. And there are other labels, for example, the team labels that I showed you. Those are contextual. Those information you or the company have. We can go back to the topology a little bit. Let's see those labels and pick, for example, the network team. And you can see that there are some appliances here, which is onboarded into Axoflow inventory. And when they are onboarded, we can identify them by IP address, FQDN, or device ID. There are a couple of automation in place for our router to match the source with the appliance. And you can see other labels here as well, like the team or the location label. And because the whole system is utilizing the labels on each layer of the system, we can use these, for example, the team label as well in the visualization. So it's very easy to add another dimension if you have some other attributes that want to organize your instances around. But eventually, we want to send those logs to somewhere. I got 3 examples here: OpenObserve, PubSub, Splunk. And another automation that Axoflow provides is that formatting the different type of logs to the specific good type, good format for the destination. So what does it mean? If we are looking on a Splunk, for example, here is a Palo Alto log. It's in the separated format, and there is a JSON formatted, I guess, a Windows log. So those formatting happens automatically. And if you want, Axoflow can send the labels that I just showed you directly to Splunk as well, or the other destination. So when your analysts, doing the queries, they can rely on, for example, the team, who is the responsible team when they have to search for root cause, moreover. Another example is OpenObserve. OpenObserve is an Elasticsearch-like collection. It uses JSON format. So when I pick the Palo Alto logs, they are in a very nice key value format. There are some syslog in raw format as well, or the JSON, but the system tries to, use the best format that happens. What is the problem if we are sending everything to OpenObserve without, changing anything? I mean, this is what you see here, these analytics and sending logs is basically without configuration. You just send the logs to your router and configure the destination, and that's it. And in this case, for example, every team logs, so if I just highlight the team label here, you see that network, application, Windows team, all the logs are mixed here together. And OpenObserve got a thing called streams. So different streams means like different index in Elasticsearch, for example. You can separate your logs based on that. So to not see each other logs, I want to separate the different teams. So I want the network team to have the network stream. I want the Windows team to have the Windows team, but everything is now going for the default. Let's fix that. We got a third view ready, the flows view. This is basically the configuration, what I want to collect and where I want to send it. You can see 3 flows I pre-configured. basically without any transformation, PubSub, OpenObserve, and Splunk. And let's see the OpenObserve. We got processing steps. It's basically empty. It's just some attribution addition at the end, so we can see the teams here. So I do not do too much with the logs. Let's see what kind of logs passing through here. Not a surprise, but you've seen in the topology, there are these Palo Alto, Windows, whatsoever logs. So let's fix the thing that I mentioned. I want to send the network team logs to the network stream. So first what I will do is I want to select the network team logs. And I already told you that the labels are traveling with the message. So when I open the event and under the match attributes, there are all the information, and I just only told the half of it. There are connector information and protocol information. Even we are labeling if the message is malformed or something like that happen. But let's talk about the host labels that I'm started with. And we got the team label here. I will just copy the path and say that the method.host.labels.team, when it equals to the value, the network, then I want to collect this message. I will just change the description that, only team equals network. I will collect. This is just, helping me to overview the different kind of rules that I'm setting here. And if I save this and clean up a little bit, start the tapping again, what I have to see is that there is much more messages on the top than in the bottom, because these are the inputs and these are the outputs. The outputs is only what I selected already, where we have the network label. So we got the network labels. Let's add one more processing step, and this will be a set field. And I want to set the OpenObserve stream attribute. And yet again, I can go to the meta, having the destination, OpenObserve. I will copy the path. This is the field, and I want to set the stream, and I want to set it to the network. I already had this here. And what I have to do is just save it, and I will just start the tapping, although there will nothing much change because I changed the value that where I want to send the log. So I have to go back to OpenObserve. I will just remove this information. There are still things going into default, but if I see the network, now you see that those logs are coming to the network. So this is how I separated them. And if I have a couple of teams like 1, 2, 5, we can do it statically. But I don't want to restrict myself to this static configuration. I want, like I got the labels. I just want the label to go directly to the stream. OpenObserve is clever enough to automatically creating new streams if they happen to appear. And I can do that as well. So what I will do is creating another step. I will use a filterx expression. This allows me to practically freely write expressions. And what I want to do is that I have this lovely stream parameter. I want to make equal with the meta.host. And I need this right here to be syntax correct. And I even can turn off this two-step before. This is very convenient. You can just, turn on, turn off steps when you're doing practicing or just, trying out new stuff. And if everything went right, logs start to flow. There is no difference in, the source and destination because we are accepting everything. Although other streams like Windows should be populated as well, and Windows apps, so all the other teams as well. So just, rephrase it with just one little processing steps. I immediately collected all the logs, parsed them, and labeled them based on the inventory labels, and sent to the specific stream or index, whatever destination to use, in the right format. Only had to do this kind of stuff. One of a good example, how to use labels if I have something custom. And one of our customers were talking about VMware servers that sometimes go crazy and just fill the log pipeline with garbage. And, they just want to stop that log flow, fix the server, and set the log flow back up, which was a troublesome action for them because they had to, they used IP tables, firewalls, whatever to do this. In Axoflow, it's much easier. You can just, shut down the whole flow if you want, but that's a bit drastic if it's only just one server. So what I suggest is that we will reuse this select. And just to avoid the lot of noise that we have, I will just select the PAN-OS logs from the whole bunch of logs. So what we have to see here, if I enable, because I forgot to enable, if I enable, then only PAN-OS logs will appear, and that's first fine. I will add one more label here, which I call meta.host.labels.silence. And when this is not equal yes, I want to collect. So I use the exclamation mark to negate that when the yes is present as a label, I don't want to collect this. So if I save this and restart collecting, everything should go as it's intended. But if I go, actually, let's just flowing, and let's search for my Palo Alto, which I can do, in the host list, just, a free text search. This is I will add the silence less yes label here. I don't forget to hit the save button. Sometimes I forgot this. And we need to wait a little bit, until the configuration is rolled out. But after a couple of seconds, what you should see here is that the logs stop flowing because we got the silence label activated. And this simulates, when the VMware goes crazy, you just apply those labels and go, fix your stuff. And you got all the other logs, flowing in the meantime without, just, breaking the tunnel. And as you can see, there is no more log coming. So I can just go back and removing the label. And when I remove this label, it's after a couple of seconds, it will go back to normal. Let's see that. So logs are flowing in and Palo Alto traffic is already there. So this was my last example. And I just want to go back to these analytics to re-emphasize that without too much configuration, a very complex use case. So I had to onboard, I have appliances, I applied labels, those are automatically enriched. And based on those labels, I'm doing automatic routing. And because of labels, we can even see, where those destination stream went. So if I just change it here for the last 5 minutes, you will see that until the stream routing was active, I was routing to the Windows, the network, to the app stream. I can even, filter that to open observe. And here you can see that in the last 5 minutes, it was perfectly routed based on the labels of the inputs. So that was my demo. And if you have any questions, this is the right time to ask it.
There are a couple questions here already, but I'm going to skip ahead to one of these because I think it's a good place to first start with, which is, do I need to know Kubernetes?
You don't have to know about Kubernetes, although the fun stuff is that the Kubernetes labels can use seamlessly within our system as well. So this is the great about labels. If you are using them in your whole infrastructure and you can, translate the Kubernetes labels in the Axorouter labels, and as Axorouter is supporting labels as well through the logging operator or telemetry controller, you don't have to know anything about Kubernetes. You can handle your Kubernetes logs on the same screen.
Okay. All right. So first question that came in, where do the labels come from? I know you sort of talked a little bit about that, but.
Yeah, absolutely. So just, refreshing your memories. So labels, most of the labels that you see here comes automatically from Axorouter based on the log content. It identifies it, that's a label, it parses it. And even if we are, tapping into the actual log, the parse content becomes label as well. So when you are, doing anything in the processing steps, you can even use those labels that parse from Palo Alto. So like the type traffic can be a label as well. So it's coming from the content, and the others are coming from contextual data, like the team label, location label, that you can apply on inventory items.
And how does the system figure out which log is what?
That's a very good question, and I will let Balazs answer that.
So there's basically a built-in intelligence into Axoflow. So we fingerprinted around 120 different vendors and their logs, and that comes out of the box with Axoflow. So you just direct traffic to Axoflow and you get them for free. They are automatically recognized, and those inferred product and inferred vendor labels that Sándor showed in the analytics screen, they are automatically enriched into the data, even if it doesn't contain anything that would otherwise indicate that this is coming from Palo Alto or Fortinet.
Yeah, I think it's very cool stuff that it doesn't matter where it's actually come from. It could come from an OTLP application that's sending OTLP logs directly, or Kubernetes, or syslog, or HTTP, or from a file or whatever. It doesn't matter for Axolotl. It actually tries to identify based on the content and try to pair the onboarded instances there.
Okay, Ken, and I think you also talked a little bit about this, but can the engineer label something specifically themselves?
Absolutely. This is more related to the environment, the inventory. And, you are picking any of the hosts and doing, random labeling. The labels are great because it's a framework and you can decide how to use it. And we help you, giving, like playbooks, how you should organize it, even help, like the onboarding, but absolutely. And I think this is a bit related to Airbag as well. And labels can be used to define the access control. So because you have, or in Axoflow, you have everything, even Axolotl got labels. You can define access control as, who can access to what type of labels. And this applies to inventory items, to flows, even log streams. So we are still working on that part of the system, but even you can define, which kind of log flows a specific user is able to tap into. Axoflow just can hide the logs from the tab that you are not authorized to see.
Very cool. Very cool. What about things like comparison of log volume and data? I know we got a bunch of stuff about that. Can you visualize the data based on them?
So that's one of the, most nice feature that in a heterogeneous system, you are ingesting into S3, into Splunk, into OpenObserve, and it's really hard to, at the end of the day, how much I built to inside my company, for example, to the network team. And the answer is here, because when you have a unified layer of ingesting data, then it's that easy. Just open a Sunburst diagram, and I would tell without the diagram that the network team is the main producer. You can just dig deep into what is producing the most data, and with the labels you can even use which vendor that I'm using. So I just click here in the network and check that, for example, Palo Alto is 30%. Of course, this is just generated data, so it's roughly the same, but you get the idea.
Yeah. If I change the labels, do I break the flows?
So that's a very good question. So actually flows built on top of the labels. So if you are fucking up something, then it can be influenced by for example, applying syntax error somewhere. But the great thing is that we have a lot of different kind of alerts in the system. So for example, we are alerting even on if the flow is not getting data it's used to. So when you mix up something and it has a drastic change in the flows, or you are not getting any logs from a specific source, for example, then the system will alert you. And you can always clone a flow and use, a dev null destination. I should have created one. You can use a dev null destination, try it out, use the test feature, and when everything seems fine, you can just, really roll it in production.
Okay, great. I think that's about all the questions I have, unless anybody else has any more they're going to drop in. I'm pretty sure that's the first time I've heard the F word in a webinar. So thank you.
That's me. I always carried away when I demo cool stuff. That's happened to me on stage as well at KubeCon.
I don't know. Mickey, can you throw up the deck? I just want to mention a couple other things. There is a quick survey if anybody wants to take the time to fill it out, if this was helpful or useful for them at all. We won't be doing this is our 4th webinar of the year. We will not be doing a webinar in May or in June. If you have any questions, as always, please reach out. You can reach me at neil.boyd@axoflow.com, or the Axoflow contact will work as well, or sales@Axoflow. All that stuff works. Please just feel free to reach out. We'd love to help you with any specific use cases. And we hope you learned something about labels today. Thank you all for joining.
Thank you, everyone.
Thank you very much.
Bye-bye.
Bye-bye.